Welcome back to my channel Conquer the Fear. So in this video I'm going to ensure that this is going to be the last video you're going to watch on this particular topic, because I'm going to cover what are records, what problem does it solve, how it is different from Lombok and Pojo. We're also going to discuss the advantages and what are the limitations of records, what is allowed in records and what is not allowed in records. Along with that, we are going to discuss different scenarios and the use cases, and most importantly, where and how you can apply this particular record concept in your live applications. So if this is what your expectation from this video, then please grab a cup of coffee or of tea and watch this video till the end. To check out the version in which the Java records were introduced, it was Java 16. Although it was a preview feature from Java 14, but it has been standardized in Java 16. So majorly it is going to simplify the creation of their data carriers in the classes. So now we'll discuss what exactly the records are. Record is nothing but a special kind of class in which it is designed to act as a transparent holder for some immutable data. Now it is a very concise way to declare the class. Now if your primary purpose is to store data, now, if you when you declare a record, the Java compiler will automatically generate a canonical constructor. What is canonical constructor? The constructor that takes all the component as an arguments and assign them to the corresponding fields. It is also going to generate the accessor methods, that is the getter methods for each of these components, that is going to be named after the component. Example, the first name is going to be the component name first name. Now is going to implement the equals and the hash code methods, the toString methods, which are derived from all the components of this particular record. Now it is going to be the private final fields for each of this particular component. Let's look what problem this particular record is going to solve. Now the main purpose of being record being introduced is of reducing the boilerplate code. Now when you go to the traditional class and you try to create a simple class, you are going to create the plain old Java object, which is, or the DTO, which is going to require some repetitive codes like this. First of all, you have to declare the private fields, then you are going to create the constructor to initialize those fields, then you will be writing the public getters methods for each of these particular fields. Then what you will do, you will implement or override this particular equals and the hash codes for comparing the object based on these fields, and then you will override the toString methods for making the string meaningful. Now this is a boilerplate code, you can see, and the intent is to reduce this particular code. The record will drastically reduce this particular verbosity, making the code much more cleaner, much more readable, and less prone to errors. Let's look out the similar options which were available before the records being introduced to the developers. Now traditionally we used to create the POJO or the DTO, and as above I have discussed, it is going to be the manual efforts for creating the constructor, for getting the getter setters, return, then equals, then the hash codes and the equals to strings methods. Now there was another option which was an external library which was called Lombok. Lombok is particularly a third party library which is basically using the annotations like at the rate data, at the rate value, at the rate all argument constructor, and so on. It is going to automatically generate the boilerplate code which is used for compilation. Now this is an effective way, but it is a third party dependency and it is going to require some plugins or support. Now record is going to offer you the language level solution itself, so it is going to remove the need of the external library. You have to basically import and write the code. Now let's look at how we can create the sample record class. In this I'm going to select the name as point over here. Now if you see, this is exactly similar to what the class creation is about. You have a public, and then instead of class you have the name record over here, and I have written point class record over here. Now inside this we can create x and int y. So this is what the record is about. Now you can have the optional custom constructor created. You can create the instance method, you can also have the instance method inside it. This is how you normally create a record over here. Let's try to create a point object over here. and this is going to be exactly similar to how we create the normal Java instance. Now you see, this is exactly, it is pointing to the record, and it is exactly similar to that particular creation. Now we'll see how we can access those particular fields. Let's say you want to access the x-axis. Now in this case, what you will do, the x-axis is going to be p dot x. So this is going to access your x, and then it is going to access your y over here. So this is exactly similar to how it is, but just make a point to note here. Now if you just check out this particular method name, it is x, but ideally in the POJO, what it the ideally the name would be get x or get y. Now let's start looking at how the code is going to look before the records and how the code is going to look after the records has been introduced. So I'm going to explain with the simple examples. Now just have a look at this particular traditional way of creating the POJO class, or before the records, how we used to create that. We used to create a final class, then we used to add the final variables, and then the constructor for that initializing them, then the getters methods over here. Ultimately we used to have the implementation of equals method, and then hash code, and then toStrings method. So this is was all the code we used to have to manually write before the records. So this is quite elaborated, this is quite boilerplate code. So that is the reason Java has find an option of records where you can actually easily create without having to write this particular boilerplate code. Don't you think this is going to be a pretty large effort if you are having n number of POJOs like this, that you are going to create lot of classes like this, and this is going to be a lot of boilerplate code. So that is the reason record is quite beneficial. The traditional way, what we used to do, we used to create the class like this. We used to instantiate the three objects, and then ultimately if you wanted to create or call this particular any of these particular attributes, then you used to call this particular with the get name over here. Take a look at this particular version of code where I've created this particular product class with use of records. Now the class is being record. You have the manual constructor created over here. You have this particular fields over here added. Now you have this particular, we can add this particular custom methods, and you can construct a creator if it is needed. So here is the sample, and if you see, there is a method which is custom method which we can define. So earlier example, whatever we have seen for the record, it was just the variable names and introduced over here. There was no constructor added and the methods over here. So this is how you create. Let's look at the implementation. Now once you have this particular record created, you can create exactly similar to how you can instantiate the normal class. Then you will print all this particular thing. But if you see here, the product name over here, now this is going to directly get that particular with the name itself. It doesn't have to get that particular name access with that particular methods. So this is how you normally write that and access those particular attributes. If I click on this particular name method, it is going to refer to this particular attribute. One more thing to note in this particular is that we are going to do some validation checks and throw some exception over here inside this. So you just check out the way how we have created this particular constructor, and then we are making use of it. After looking at this, don't you think this is much more concise, and it is much more significantly improved from what we write as a boilerplate code? So this is going to, the compiler is going to handle all the boilerplate code like equals, hash code, toString, constructor, and the access method. Just start looking at the important points with respect to the records. Now the first part is immutability. Now all the components of the records are implicitly final. Now once a record instance is created, its state cannot be changed. Now this is going to promote the thread safety. Also it is going to be much more easier to use the data. Implicitly final. Now the records are implicitly final. That means you cannot extend by other classes or the records. So this is going to ensure the data carrier nature of it. There is a canonical constructor which is created automatically by the compiler, and that is the reason it is called canonical constructor. So you are going to define your own constructor to perform the validation and transformation on the inputs, but it must be called implicitly the constructor, or it is going to initialize the all the fields. Now this is going to be the compact constructor, and it is going to be very concise way to define your canonical constructor. Now, where you only write that particular code or the body, the parameter list and the fields assigned, which are going to be implicitly handled over there. The getter methods are going to be named identical to the component name. So instead of get name, which used to be in the POJO style, you can directly call it with the name over there. Then comes the no setters over here. So due to the immutability concept, records do not have the setter implementation. Now, when you're talking about reflection, so it has been updated to supports records as well. Now, this is going to include is record. There is going to be having a get record component when you're trying to do the reflection API calls. Now, we'll discuss what exactly are allowed in records now. Now, if you take a look at this, it is going to create the instance method. So you can create your own instance methods like how we declared for that particular total cost in the example. Then we can define the static fields and the methods. So whatever you can declare the methods as statics, and you can declare static fields and the methods. So all the fields you can define like that. Then the compact constructor, which we already talked about, where you can do the validation and transformation over there. You can also create the non-canonical constructors. So you can define your additional constructor over there, but that has to be delegated to the canonical constructor using the this method. Then you can implement the interfaces. Now records can implement another interfaces. If you go to the nested classes and the interfaces, you can define the nested classes and interfaces inside the record as well, how it is similar to the class. Then comes the records, that is going to be the generics. So records can be generic over there as well. Now just to showcase you, you cannot extend that particular record. Now this is a class where I'm trying to record the product record. Now you see here, this is going to give you an error that you cannot extend that. So this is an implicit behavior of records. Discuss about the limitations and what records cannot do. First, we already discussed that record is cannot explicitly extend any class. Now if you take a look at this, how similar to the object class, if you open this particular object class of the hierarchy, you will see there is nothing which is going to extend or import. Now similar to this, if you compare it with the records, this is going to be exactly the same case where it is going to implicitly extend from the records. So this is how the implicit behavior of records if you're trying to create a record. Now just take a look at the second option, that is it cannot be extended. So that means the records are implicitly final and they cannot be subclass. Now if you take a look at this example of subpoint which I've created a class and I'm trying to extend that particular point over here. The point is what? It's a record class. So it is not allowing to extend and create a class out of it. Now, there is another limitation, that is it cannot be declared as an abstract. Now, if you try to create an abstract, this is going to show you that it is not allowed here. Now, this is going to be an important record interview question because interviewer might try to confuse you that whether we can mark the class as an abstract record for it, because normally we do with the classes. Is this applicable for records as well? The answer is no. Another limitation is you cannot declare the instance fields. So all the instance field must be part of the record header component part. You cannot add that particular private non-static fields inside this particular record body. So if you try to create, let's say ABC over here, now you see it is going to say that the instances field is not allowed in the record here. Now, records cannot have native methods. You cannot declare the native methods how in the API of the Java we can create, right? So you cannot create in records case. then only the getters are there. There is no setter methods being there because of its immutability nature in of records. Another important point is when you are using dealing with JPA entities, it is not ideal to use them, because while some of the workarounds which exist are being explored, but the records traditionally don't fit with the JPA entities, because JPA is often going to require the no argument constructor. It is going to have the mutable fields, which is going to have the setter methods. So the relational mappings, which is going to require in JPA, which records don't provide by default. And if you look at the last option, that is shallow immutability. Now records is going to have this shallow immutability if the record component is mutable. Let's say you have a list. Now the reference to that particular list is final, but the content of that particular list still be modified over there. So you need to be very mindful. If you want that particular deep immutability, then in that case the record is not an option for it. Now we are going to look at the various scenarios to use the records with examples of the real world. Now we'll see the records are very ideal for some situation. So we'll discuss the very first thing is DTO transfer objects, that is data transfer object. Now let's take a scenario in your web application. Let's say in your Spring Boot REST application, you often need to define some objects which is going to transfer your data between the client and to the server, or in between the different layers of your application. Now if you look at this is the DTO which is going to be required for creating the new user. Now if you see here, this is going to be the name of that particular. Now you see record is there, this is the DTO name, and then this is going to be the string username, email, and the password. So this is going to be similarly act as an DTO for you, so where you doesn't have to write the boilerplate code which we used to write when you're creating the DTO. Let's take at the second example. This is going to be the DTO for your user details, where we have ID, username, and the email. So this is where it will be used as an for that particular operation. Then the second option is configuration properties. Now if you open this particular class, now let's look at this particular scenario. Let's say your application often have some configuration settings. Now that has to be loaded once and it has to remain constant. Now in that case, we can create one app config, then we'll have the database URL, you'll have the username and the password. That's where it is very useful when you're trying to create such configuration classes as well. Then comes the value objects. Now if you are, let's say you have some domain specific values that are defined by your attributes, and you have no identity beyond those particular attributes. So let's say you wanted to define some coordinates, you want to define some money amount. In that case we can make use of it. Now let's take an example of that. Now if you see here, this is going to represent a monetary amount with such currency over here, so that it is going to be same thing whatever we are going to write here. So the with respect to money, there is going to be the amount and the currency. So the attributes which we are going to define will have no identity beyond this. Now similar for the point also, you'll have the x-axis and the y-axis, which is going to be related to that particular point only. Now you can return some multiple values from the method. So if you want to return something as a method which you're going to return two values or three values, in that case we can use. Now let us take a look at that particular classes. Now we have this particular record created where you have minimum and the maximum. Okay, and after that you will create a class over here. You can actually have this particular implementation. Now in the main method, I'm going to get the data, so I'm passing this particular data. Out of that I'm going to get the minimum and the maximum. The logic will be written in this particular method. Now if you make a note of this, the return type is min max. Now if you see, this is going to record ideally. Now if you want to return something here like this as a minimum and the maximum, so this can be according to your business logic, and it is going to be the perfect fit where you want to only return this two. Let's say this, in this case it is going to be only two, But yeah, based on your logic, you can define the business logic over here, and then you can return it. So this will be useful in any location or any business logic. So I'm sure, like, you must have written different collections to write this particular, to achieve this particular functionality, but making use of this particular record makes it quite easy for you to avoid those extra business logics to be applied or extra logic to be applied. Simply you can return this. Now, there are some intermediate data structures which is going to be used in the streams or lambda. Now, if you are going to look at this particular scenario, we are going to, let's say you want to process some data with Java streams. Now, you might need some temporary objects to combine, to transform that data before you assign it to the final collection. Now, records can be used up particularly in this particular situation. So, the records declared with this particular method can be used up over here. Now, if you see here, student processor. Under this, I have defined two records. Now, student with the name, age, and grade, and then the student with the name and average grade. Summary, basically. Now, if you take a look at this, the main method, I'm trying to create the instances over here. Now, just take a look at this particular process method where I'm trying to pass the list over here. And then in this particular streams, I'm going to filter over here. Then on the collection, then before, under this particular collection being applied over here, I'm going to see that, I'm grouping that, I'm going to average it. Then I'm going to take an entry of that particular, from that particular entry set, I'm going to create the stream over here. Then if you take a look at this particular entry, I'm going to take summary over here. See here, the key and the value. See the average and the discovery of that, right? Then I'm going to compare it, sort it, and then apply it in the list over here. So that's how we can make use of this. Now, that's how you apply this particular scenario. Records are one of the important steps when you're dealing with data centric classes, when you're trying to promote the immutability. You want to reduce your boilerplate code, and you want to write a clean and the maintainable code. So this is one of the best way to write now. And that too, you don't have to explicitly add the dependencies, or you have to make the old way to write that particular boilerplate code. This is pretty concise and more readable way to achieve their functionality. If you have watched this video till the end right now, thanks for watching. Please share it with the needy people. Also, don't forget to like, subscribe, and hit the bell icon. Thank you for watching.